All right, thanks everyone for coming. I'm James Ward. I'm a platform evangelist at Salesforce. So at Salesforce, we're big Kafka users, but also provide Kafka as a service. So that's how I've been getting into Kafka lately. So this talk is intended to be a bit of an introduction to Kafka. So how many people here have done Kafka before? Okay. So some stuff that Jay went through quickly in his keynote, I'll go into a little bit more detail on. And then we'll do a little demo and also show how to use Akka streams with Kafka. So that's the plan. Feel free to ask me any questions as I go. Okay, so some quick fundamentals about Kafka. It's an event stream that's distributed and redundant. So it's distributed across a cluster, so you get redundancy with the data in an event stream form. So uses messaging system semantics. So a lot of the vernacular that you'll see with Kafka should be familiar to you if you've done any sort of messaging stuff. So we'll see that as we go through. And one of the things that I really like about Kafka is that the clustering part of Kafka wasn't an afterthought. It was really one of the core design parts of Kafka. So it wasn't just bolted on later. It's really core to what Kafka is. And then another core part of Kafka is that it provides durability and ordering guarantees. So some of the use cases for Kafka, what I have seen it used for is things like modern ETL and then CDC, so change data capture. That's pretty common uses for Kafka. Data pipelines is what I think probably the majority of people are using Kafka for, is building these data pipelines like Jay talked about, hooking together analytics with all sorts of other integration tasks and those sorts of things. So, and then we also see Kafka being used quite a bit for big data ingest. So this could be IoT devices, this could be interaction events, all sorts of different things. But when we've got tons of data coming in, Kafka can provide a buffer for us for handling those events. Okay, so that's kind of our background. Let's talk about what Kafka actually is. So one of the core piece of Kafka is something that's called a record, or could also be called a message or an event. And what a record is it's something that has a name, a value, and a timestamp. It's immutable, append only, so and persisted. So essentially this is a log. And because this is built into a cluster, it becomes a distributed log. And so that's what a record is. And sorry, I'm going fast, but we have 20 minutes. So okay, so we have producers and consumers in Kafka. So in Kafka, there is a broker that's a single node in the cluster. And then the way that we interact with Kafka is we have producers that write records to a broker, and consumers that read records from a broker. So it's important to note that consumers aren't actually pushed records, they actually read, and they do that with polling, and you can set the polling window. It's a little bit different than a traditional messaging system in that way. And there's some reasons for that we'll talk about a little bit later. So Kafka has a leader and follower architecture for how it manages the distribution of data across the network. So usually when you connect to a node, you're going to publish to that node, and then there's going to be follower nodes that will then get that message and percolate it down. So leader-follower distribution. Okay, so now is where Kafka starts to deviate a bit from traditional messaging systems. We have topics, and those are really just a name for something that groups together one or more partitions. And a partition is the way that we get our horizontal scale in Kafka. So a partition is actually can exist on a different node within the cluster. So this is how we can now have our partitions that are scattered across the cluster, and so then we can do our horizontal scaling, traditional like sharding way of doing things. So the partitions are replicated. You set the replication factor in your configuration to determine how many copies of a partition there will be. Then ordering is guaranteed only for a partition. So this is where things get a little bit tricky with ordering, is that when you're dealing with writing to a topic, really you're writing to a partition within a topic, and the ordering in Kafka is only guaranteed for that partition. So the way that it works is you'll have a producer that's producing new records, appending new records onto a partition, And we'll talk about the offset IDs in a minute for how that works. But the ordering is only guaranteed for a single partition. So across a whole topic, there's not really an easy way to get ordering. There are timestamps on messages, so you can use the timestamps to do some sort of ordering, but it's not going to be guaranteed like it is with the offsets. Okay, so then the offsets. So the offsets are these sequential IDs that are written, assigned to every record when it's written. And so you can see in the diagram that each partition has its own sequence of IDs within a topic. So when you work with Kafka, you're subscribing to a topic, you're publishing to a topic, but then there's the partitions underneath where the ordering is applied, and the partitioning across the cluster is also applied. So what this means is that your consumers have to actually keep track of their offsets. They have to keep track of where they are in reading through the data in a partition. So when your consumer subscribes to a topic, it can subscribe to a partition within a topic and say, all right, I'm going to start reading at this particular offset ID and then continue reading from there. So the benefits of this is that you can do things like replay. So this is something that Jay talked about earlier, where your consumer can actually go back in time and say, all right, let's start with this ID, and if I need to reprocess any data in the stream, I can always replay back to that ID and then roll forward from there. But usually you would do that per topic because that's where your offset ID is based. If you want to do it across partitions, then you'd have to maintain the offset IDs for the multiple, the different partitions. So another interesting thing that this supports is consumers that are operating at different speeds. So this has now become a very common thing with our data pipelines, is that we'll have different consumers that are being able to process data at different rates, and you want to be able to handle that without slowing things down. And so that's, each consumer can be at a different offset and reading at a different rate through the partitions. Okay, so that's our offsets. And then another nice feature that they've kind of wrapped around some of this to make for a bit nicer developer experience is this idea of consumer groups. So with consumer groups, we now assign a name to a group of consumer nodes, and then what that can do is that can essentially load balance the messages across those different nodes and make sure that a given message is only going to be delivered to a single consumer node within a consumer group. So we get a bit of load balancing without having to deliver the messages to all the nodes through consumer groups. Okay, so let's check out a demo, quick little hello world demo here of how this all works. So let's go see. So I've got a local Kafka server up and running, and then I have a producer and a consumer, and we'll go through the code for those. But 3 different processes in this case, the server, the producer, and the consumer, and all running on my machine. Okay, so let's go first check out, before we go into the code, let's check out the actual demo here. Okay, so you see that what's happening in this case is I have a web application in this case, and it is connected as a consumer of messages from Kafka. So we're seeing those messages come in, they're being pushed over a WebSocket. So the first number here is the offset. And you'll see that I'm getting the sequential IDs for the offsets. So that's good. I've got those numbers. But one thing you may notice is that all these numbers are unique. So what that actually means is that in this case, I only actually have one partition, or I'm only subscribed to a single partition. If there was multiple partitions, then we'd be seeing duplicate values in those sequential IDs because the numbers are only unique across a given partition. So in this case, when I created my topic, I only created a single partition for that topic. And then the second value here, this is the actual message body, the message value, and it's just a random number. So it's a very boring data set here. But let's pause this because this is where we can now see the ability to do the replay. So right now I've actually disconnected my consumer, so it's no longer connected up to Kafka. And what I did was I tracked my offset. So what was the last offset that I saw? And that was this 4637 number. And so now if I go in and say, all right, let's resume this, then you'll see that if we scroll down, there we now got all the messages that were sent from when I paused it, and then now we're back at real time getting the messages that are coming in. Okay, so that is just showing that, hey, you know, we can roll back in time to previous offset ID and start reading from there and then catch up. So in this case, in Kafka, there is durability settings, so you can control the window of time for how long it's going to keep messages actually on disk in the cluster for. So the default, I think, is a week, but you could increase that up as long as you want. You could also increase it based on the number of bytes that you want to keep around, and that's how you would decide how long to actually keep these messages in the Kafka cluster. Okay, so that's our very simple hello world application. Any questions so far about basics of Kafka or the basics of Kafka or the demo here? Questions so far? Yeah, go ahead.
Sorry. Maybe I noticed wrong, but when you resumed it?
Yep, there was two. Yeah, good thing. Yeah, so I should have a prize to give you for noticing it. So the way that I actually, the question was, there was two repeated numbers in the stream. So if we look down, find that number, you'll see that there's that 4637 when I paused it, and we see that actually twice in the stream here. So why is that? So that's just an artifact of the way that I had it resubscribe, is that I know my last offset that I read, and so when I resubscribed, I gave it that offset, so that's where it started me. What I should have done is like incremented that number by 1 or something and said, okay, I don't need that first record because I already processed that one. So yeah, good catch on that one. But yeah. Okay, any other questions about basics of Kafka or how this is all working? Yeah, go ahead.
Do we need to consider duplicate messages or something?
So duplicate messages. Yeah, so the consumer, when it subscribes, it's just going to get the messages from the offset point that it subscribes at, which could be the latest offset, and then it's going to get just a single delivery of the messages from there. So the consumer can actually control how what's going to happen when it's going to actually control, have I actually processed this message? So that's something that you need to keep track of on your own, is which messages have been processed. And so what you can do is you can store that offset ID of how far you've processed through the stream. You could store that in Kafka. You could store it in a database. You could store it wherever you want. But you do need to keep track of that offset ID so that you know how far through the stream you actually processed. And then depending on the client that you're using, you can control whether or not you want to guarantee delivery at most once. And then there's some other settings that you can control as well. Yep.
Yeah, when a topic is split into partitions, do those partitions replicate each other, or do they each have a different subset of data?
So each partition is fully replicated onto the other node. So each partition will have a leader and then followers. So the partitions are actually replicated from a leader to a follower. So each node should have the full partition.
Okay, so
yeah.
a subscriber only reads one partition.
A subscriber can subscribe to one or more partitions. So it subscribes to a topic and then can be more selective within the topic if it wants to. So I guess there's like 3 different layers of subscription. You can subscribe to the whole topic and get everything on that topic. You can subscribe to a topic and then a partition within, or many partitions within that topic, and then you can subscribe to a topic, a partition, and starting at a specific offset within the partition. Yeah, so different granularity. So in this example, the way that I subscribed initially was to subscribe to the whole topic, so everything across the whole topic. And then when I reconnected, I had to actually subscribe to a specific partition. We'll see this in the code in a minute. I had to subscribe to a specific partition because I have an offset ID that's specific to a single partition. So I had to subscribe to a single partition in that case. if I wanted that to work across the whole topic, then I'd have to keep track of, for each partition, what's my offset. And in this case, just simple example, I just was keeping track of a single offset. So this example would only actually work with a single partition, the way that I programmed it.
So when you resumed, why that the last position? I mean, like it drops all the way down the screen, but instead
Yep.
instead of starting from the top of the screen.
Yeah. So it's just taking every time it gets a message. So the question was, why is it all scrolling down? So every time it gets a message, it's just pre-pending that message into a list, and so that's why all the data is pushing down. Okay, so that's a quick demo. Let's move on to the code. And where did my slides go? Okay, well, I guess I don't need slides. Okay, so the code that I'm using here is using something called Reactive Kafka, which is a library for Akka streams. Akka streams is a really basic source sync system API, and in the case of Akka, it's built. In the case of Akka streams, it's built on top of Akka. But there are other implementations for what's called reactive streams out there as well. Okay, so this is using Reactive Kafka. So let's go through some of the code for this little demo. So I have a Kafka class here. I'm doing some SSL config, which is actually not being used in this case. That's only being used when I run on Heroku, because Heroku requires SSL to connect to Kafka. But here's where we get into the interesting stuff. First, I have a producer settings, and the producer settings uses a string serializer. So we need to give the producer a serializer for the key and for the value, and in this case, I'm just using strings, so pretty easy there. Then I give it my bootstrap servers. Kafka uses Zookeeper underneath the covers, so that's actually what we're bootstrapping based on. And then similarly, we have consumer settings, and in this case, we need a deserializer, so I'm using a string deserializer for my consumer. So I give it that for the key and for the value, give it my bootstrap servers, and then I give it my group ID, which in this case I'm not really using, but that's how we group together multiple consumer nodes so that only one node within the consumer group will get each message. So now here's where we use the Akka streams part, is we have both a source and a sink. So the sink is a sink of producer record. Producer record comes from the Kafka API. And we're going to create just a plain sink, give it those settings, and that's how we now can have a sink that will dump messages into. Then we have a source, and a source takes a topic and then maybe an offset, and that's a source of consumer record. So we look at that offset. If it was not specified, then we're going to just subscribe to everything on the topic. If it was specified, then we're going to subscribe to a specific partition using the offset that was specified. So that's what happens when I reconnect. And then I create my consumer plain source. Okay, so now my producer, here's what I'm doing is I'm creating a source tick that's going to tick every 500 milliseconds. It's going to produce a random number. And then we're going to take that tick source, we're going to transform each of those random numbers into a producer record. So that's from the Kafka API. So we need a producer record to be able to write into Kafka. And then we just say, all right, send that data to the Kafka sink. And so now that's what's actually producing those records to Kafka. Then on the consumer side, I have my web application. This is using Play. Play uses Akka streams, so now it's really easy to wire together the WebSocket with the Reactive Kafka. So what we do is we check to see, do we have an offset that was specified? We create a Kafka source from the random numbers topic. We give it our maybe offset. Then we're going to get a consumer record every time one of those is received. So then we turn it into JSON, and then we wire together the WebSocket with that Kafka source. And you'll see that there's a sync.ignore, and that's because incoming WebSocket messages I just ignore. So that's why we do that. Okay, so that's our Scala reactive Kafka code that's hooking all that together. So you can see, pretty simple. I really like the reactive Kafka library. It makes working with Kafka super easy. So Okay, so that's the code. It's all up on my GitHub, so github.com/JamesWard, and you can find the Hello Play Kafka repo in there if you want to go through all the code and run it on your own or run it on Heroku or whatever. Okay, I'm just about out of time, but are there any last questions about Kafka? I know that was quite the whirlwind, but I hope you stuck with me. Yep.
I was just wondering how Kafka handles repartitioning.
Repartitioning, that's a topic I don't know. Yep. Does somebody know how Kafka handles repartitioning? Command line tools. So like changing the partition, the number of partitions. Yep. Right. So it has to be done, as far as I know, it has to be done manually. Maybe there are some tools that exist. On Heroku Kafka, I use the Heroku command line to change my partitions, create topics, and change partitions on them.
You can change that in runtime without any downtime.
You can change it at runtime automatically using machine learning.
You can scale it up, but you can also...
You can scale it, add partitions, but not remove partitions. Okay, I'll be around all day, so if anybody has any other questions, come find me, but I hope that was useful. Thanks for coming.